Hello guys, so we are going to continue the discussion with respect to linear algebra. In our previous video, we have already seen about addition of two vectors. We have seen the applications of them. With respect to the coordinate system, also we understood like what does addition looks like, right? Now in this video, we are going to discuss about multiplication of vectors. And again, we will follow the same mechanism. We'll also understand the applications with respect to data science. And then again, we will be considering various use cases, scenarios, various fields like NLP, natural language processing, and many more. Now, whenever we talk about multiplication of vectors, there are specifically three different types of multiplication of vectors that we usually do in the data science field. One is something called the dot product. Okay. So this is nothing but dot product. Dot product is also called as inner product. Okay. So we will have a detailed discussion about what exactly is dot product. Coming to the second type, which is basically called as element-wise multiplication. Element-wise multiplication. Okay. And third, coming to something called as scalar multiplication. Scalar multiplication. So one by one, we will go ahead with each of this particular topic and we'll understand it in depth, again considering the coordinate system. Then after that, we'll also be seeing with respect to the application part. Okay. So let's go ahead and first of all discuss about something called as dot product. Dot product. Now, what exactly is dot product? We'll try to understand. Okay. First of all, we will go ahead and provide the definition. So the dot product of two vectors results in a scalar and is calculated as the sum of the products of their corresponding components. Okay. So here I've just written the definition. The dot product of two vectors result in a scalar and is calculated as a sum of the products of the corresponding components. Okay. Now, when we say the dot product of two vectors, it results in a scalar. So let's consider that I have a vector. Let's say this vector is of 2 dimension. Okay. Just for simplicity, I'm taking this example. So let's say that this dimension is nothing but 2, 3. And if I take another vector, which is like 4, 5, right? Now, during this particular scenario, if I say, hey, what is the dot product of A dot B? Okay. We will basically use the dot product like A dot B. It is very much simple. What we do is that we take every element, like let's say we take 2 and we take the 4 value. So this is basically my x coordinate and y coordinate, similarly x coordinate and y coordinate. So let's take the first x coordinate of both this particular vector and we will go ahead and write 2 multiplied by 4. Okay. Then as we said, right, over here it is calculated as a sum of the products of the corresponding component. So this is my first component. So 2 multiplied by 4 plus 3 multiplied by 5, right? So once we take this specific value, it is like we will take this component and this component, we will multiply them and then we'll be adding up with the next component, that is 3 multiplied by 5. So once we go ahead and calculate it, it is nothing but 8 plus 15, which is nothing but 23. Okay. So over here, 23 is nothing but it is my scalar value. And this is what a definition talks about, A dot product of two vectors result in a scalar and is calculated as a sum of the product of the corresponding components. So we basically take each of these components with respect to the coordinate and we multiply them and then we add them. Okay. Now, Usually there is also one specific thing that comes into picture. Okay, so let's say that if I take a dot product of B transpose, usually whenever we do this kind of operation, we have to probably take the transpose operation of the other vector. So let's say I am probably doing the transpose of this. The transpose of 4, 5 will be nothing but we will be writing this horizontally, right? And then what we do, when we do the specific dot product over here, this will get multiplied by this, and this will get multiplied by this, and we'll be doing the summation of the specific value. Usually in most of the use cases, what we do is that whenever we need to do the dot product, we really need to transpose one of the vectors. Okay, so this will be nothing but 2 multiplied by 4 plus 3 multiplied by 5. So this is also one way of representation that we specifically use. The reason why I'm showing you this, because even in machine learning, even in deep learning techniques, we use this kind of transpose technique, right? So this will be 8 plus 15, which is nothing but 23. Now this is fine, but our main idea is basically to understand with respect to the coordinate system and why this is really important in data science, So we'll consider some of the use cases also. So guys, now here you could see that we found out the dot product of A and B, but it is always important that we try to visualize this in the coordinate system and how this entire dot product specifically happens. Okay, so here what I'm actually going to do, I'm going to create a coordinate system with respect to x and y coordinates over here. So this will be my x coordinate, this will be my y coordinate. Let's say the values are 1, 2, 3, 4, 5, 6, 7, and here I have 1, 2, 3, 4, and 5. Okay, similarly, let's see in the negative direction, I have -1, -2, -3, -4, -5. Okay, and finally here also I will just go ahead and write -1, -2, -3, -4, -5. Now see, in this coordinate system specifically, you'll be able to see that if I consider two vectors, let's consider A over here. A vector is nothing but 5, 0. Okay, and B vector, let's say it is nothing but 2, 2. Okay, so when I say 5, 0, that basically means it will be representing this point, right? So from the x-axis 5 and from the y-axis it is 0. So if I probably consider this particular vector, it will look something like this, and it is in this direction. Okay, now let's talk about the other vector B, right? So the other vector over here B is specifically 2, 2. So it basically denotes this one, right? So this is 2, 2, and this is 5, 0. Now see, this will be this vector, and this vector is basically going in this specific direction, right? So now our main aim is basically to take this A vector, do a dot product with B. So mathematically how it can be done. I will take 5 multiplied by 2 plus 0 multiplied by 2, which is nothing but 10. So my final scalar value is basically 10. Now with respect to this coordinate system, let's see how this is 10. Okay, so I will take this entire value over here. I will put it over here. So this will be my calculation. Okay, now let's see over here what we are specifically doing. Now when we do the dot product of A and B, I'm actually getting the value as 10. Okay, now the most important thing over here is that how do we see this in coordinate system? Okay, or how do I prove this specific multiplication or dot product that I'm doing? How do I get a single scalar value over here? So with respect to this coordinate system, the answer is very simple. What we do is that we take one of the vector. Let's say we will be taking this particular vector. This vector is denoted by B. Then this vector is nothing but A, right? We will take this vector and we will project this into the other vector. So this vector, you can see this is the direction, and this vector, this is the direction. Now what I'm doing, I'm taking this particular vector, I'm projecting it to this particular vector. Okay. Now when I project this, I will denote this as B dash. Now understand one very important thing that I will mention over here. Okay, I will go ahead and see the length of this. Okay, and we basically say length of projected B vector. Okay, B vector. Then we will take this length. Okay, whatever length is there, we will take this length of projected B vector, and we will specifically multiply this by length of vector A. And what is the length of vector A in this scenario? It is nothing but 5, right? If I'm probably seeing this, it is nothing but 5, right? This is basically my length. So once I do the product of this will basically give me A dot product of B, right? If you don't agree with me, just go ahead and put the values. Right now, when I project B to this particular vector, my length of the projected B is nothing but 2, right? Now you may be thinking, Krish, why did I take 5, 0? To just make our calculation pretty much easier. So the length of the projected V is nothing but 2, and we do a dot operation with, or we do a multiplication operation with the length of the A vector. The length of the A vector is 5. And here you can see that I am also getting the same output, that is 10. Okay. So just by seeing this, you'll be able to understand the kind of operation that we have done over here, and this is almost same, right? And this is what usually happens when we do a dot product. Okay. Let's take one more scenario. This time I will go and take -5, 0. Let's say my A over here is -5, 0, and my B over here is 2, 2. Now understand one thing, the product or the dot product of this is a positive value. Why it is a positive value? And imagine this scenario. Once I did the projection, you could see that this vector is also falling or is pointing in this direction, right? Once we probably project this particular vector to this particular vector, right? The direction is same, right? When the direction is same, the value is going to be positive. Now let's take this scenario when I probably take -5, 0. -5, 0 is nothing but it is this line, right? So this is my vector now in this direction, okay? In this direction. And if I consider this point is basically -5, 0, okay? Then I'm multiplying with 2, 2, right? 2, 2 is nothing but, if I do this particular dot operation, it is 5 multiplied by 2 plus 0 multiplied by 2, which is nothing but 0, okay? Now, when I have this 5, 0, right? And here you have this 2, 2. Now you can see that this particular vector is in this direction and this vector is in opposite direction, right? What I will do, I will extend this vector towards this direction, and let me go ahead and project this. But remember, right now this particular vector which I am drawing 5, 0 is in this direction. It is in this direction. So what I will do, in order to project this, I will extend it to my other axis. But remember, this is the direction, and I will project it over here. So after projecting it, I know what is the length of the projected B. It is 2, right? And what is the length of the other vector? It is -5, right? So in this particular scenario, when I go and do this particular dot operation, I know that my length of the projected B is 2 multiplied by, what is the length of A? It is nothing but -5. So finally I'll be getting -10. Now here you can see, why do I get -10? Because the vectors are in opposite direction. This particular vector is in this direction, this vector is in this direction. So when it is in opposite direction, I'm going to get a negative value. Okay. Now guys, I will take one more example. Let's consider that my B vector is nothing but 0, 2. Okay. 0 in the x-axis and 2 over here. So this will basically be my vector. Now, if I do the projection of this particular vector, I'll be coming over here, right? Now, when we come over here to the origin, the displacement is 0. So 0 multiplied by this -5 or 0 multiplied by this 5, it is going to become 0, right? So this basically indicates that over here, if my other vector, if it is projecting towards the origin, right, my entire product or dot product is going to be 0, right? So in this particular scenario, you will be able to see A, B, if I do a dot product, it will be exactly 0. And when this basically happens, when we project the vector to the origin, because there will be no displacement, right? So these are the 3 scenarios that you can probably consider with respect to the dot product. Now it's time that we try to understand some important things and applications of dot product in data science. Okay. So let's go ahead and discuss about applications of dot product in data science. And I'll just take one beautiful example, and probably this example is being used right now also when we specifically work in the recent Gen AI apps, right? Some of the application in Gen AI are like a RAG system, right? RAG system, retrieval augmented generation. Now, why it is used in RAG system, we'll talk about what exactly is RAG system and all, okay? But where do we specifically use this dot product? One of the very important concepts that we specifically use is something called as cosine similarity. Now, what exactly is cosine similarity? Let's discuss about this. And what we are going to do is that we are going to probably discuss this with a very good example, okay? Now, first of all, we will go ahead with the definition. What is cosine similarity? It is a measure used to determine how similar two vectors are. Okay. It is basically used to determine how similar two vectors are, and this calculates the cosine of the angle between two vectors, providing a similarity score that ranges from -1. -1 basically means dissimilar, okay, to +1, which is completely similar. Okay, when I say -1, it is the complete opposite. Okay, if we go towards +1, it is completely similar. So this is basically cosine similarity. Now let's talk about this very important topic. Okay, and usually the cosine similarity is given by the formula cos theta is equal to A dot product divided by magnitude of A and magnitude of B. Okay, so here we specifically use as a dot product. Okay, and here you can see that A dot B is nothing but a dot product of this particular vectors. Okay, let's take a very good example. Okay, and this is heavily used in a recommendation system. Now, what is recommendation system? Let me go ahead and talk about this in a simplistic way. I hope everybody may have a Netflix account. Okay. So in Netflix, let's say you are seeing an action movie, right? What happens? You see this action movie. Let's say you complete the entire movie. The next step that you will be getting is recommendation of other action movies. Recommendation of other action movies. Okay, let's consider over here that you're seeing a movie which is called as Avengers. Now, Avengers is one kind of movie, and let's consider that Avenger is represented in a vector of 5 dimension. Let's say the values are something like this. Okay, 1, 2, 0, 3, 1. Let's consider it. Okay, how this Avengers is basically converted into a vectors, why we are representing this particular vectors. It may be with respect to different parameters. Let's say the first vector is basically assigned based on a feature called as action. The second vector may be assigned based on a feature called as comedy. The third may be drama, right? Fourth feature may be assigned, or fourth vector that may be assigned is with respect to let's say I'll go ahead and write romance. Okay, so some of the features will take, and this is how Avengers is represented by this number of dimensions. So the 5 dimension feature are action, comedy, drama, and romance, and it is represented by this particular number. Okay, and there is another movie which is called as B. Okay, I'm not telling which movie this is, and let's say that this particular movie has a vector with respect to 2, 0, 1, 1. Okay, it has this specific vector. Okay, now my main aim is that, let's say if a user watches this movie Avengers, then whether he or she should be recommended with this particular movie B. Okay. So how do we determine this? This is basically determined by calculating the cosine similarity. If the cosine similarity is high towards 1, then we will go ahead and recommend this. If it goes towards -1, that basically means this movie is the opposite of this movie. Then obviously I will not go ahead and recommend them, right? Because this movie may be a completely romantic movie, okay? And Avengers is like action, drama, all those movies is there, right? All those features are specifically there. So let's go ahead and see how do we go ahead and calculate the cosine similarity based on this vectors, okay? So the step 1 is nothing but we go ahead and calculate the dot product of A dot B, okay? So what is A dot B? It is nothing but I will go ahead and write 1 multiplied by 2. So A dot B is what, right? We will take this vector and we will multiply with this. So 1 dot 2 plus 2 dot O plus 0 dot 1 plus 3 dot 1 plus 1 dot 1, right? So once we do this calculation, let's say that we are getting 6. 2 plus 3 plus 1, 6, right? The second step over here, you'll see that with respect to the formula, we really need to go ahead and compute the magnitude of A and B. Okay, so here magnitude of A and B. Now what exactly is magnitude? The magnitude of A and B means what, right? And how do we calculate the magnitude of A and B? Now in the second step, we will go ahead and compute two important things, that is magnitude of A, okay, magnitude of A and magnitude of B, okay. So guys, for calculating magnitude of A or magnitude of B, right now let us go ahead and write down the formula. Later on I will try to explain you these two topics, which is called as Euclidean norm and Manhattan norm, okay. So just be patient. So in the further upcoming sessions we will discuss about this, but just to explain you how things specifically work over here, I will just take one example just to show you that what will be the formula, okay. So with respect to this particular magnitude of A, so if I am just considering Avengers as A and B is basically my other movie, I will just go ahead and do the calculation by applying a formula which is of Euclidean norm, okay. Please remember this name, Euclidean norm. Later on I will probably explain this in one of the topics, okay. So Euclidean norm is basically calculated by, specifically for A, I will take all the vectors that I have, I will do the square root of them and I will just square them up, okay. 1 square plus 2 square plus 0 square plus 3 square plus 1 square, okay. So what this Euclidean norm is, right, I will just try to show it to you. It's okay, I will just explain it over here. Let's say that I have this specific point which is my Avengers, and Avengers right now is represented by 5 dimensions, right? 1, 2, 0, 3, 1. I know I've drawn this entire in 2 dimensions, okay, but my main aim is to show you something, okay. So Euclidean norm basically means if I really want to find out the distance of this particular vector, that actually gives me the magnitude, okay. Now in order to find out this particular distance, I need to find out the distance from origin to this particular point, right? Now in order to find out the distance between this origin to this particular point, it is very simple, So according to Manhattan distance, according to Euclidean distance, if I have 2 points, okay, if I have 2 points, let's say this point is x1, y1 and this point is x2, y2. So in order to calculate the distance between this 2 points, we basically use a formula. Let's say the magnitude of A will be root of x2 minus x1 whole square plus y2 minus y1 whole square. Now what is x2 over here? x2 is this value, x1 is this value, y2 is over here, y1 is over here. Now as you all know, I'm starting from origin, so all these values will be 0, right? So when all these values are 0, then what I'm doing, I'm just writing 1 minus 0 whole square, 2 minus 0 whole square, 0 minus 0 whole square, 3 minus 0 whole square and 1 minus 0 whole square, right? So that is the reason I'm actually getting this as magnitude of A, okay. And if you further do this calculation, this is basically called as, it will be approximately equal to 3.872. Similarly, if I want to find out the magnitude of B, again I have 2, 0, 1, 1. So let's say this is my another point. If I want to find out this specific distance, then I have all these vectors and I will just do the division, subtraction with respect to this. So here I will be getting 2 square plus 0 square plus 1 square plus 1 square plus 1 square. So finally I will be getting root of 7, which is nothing but 2646. Okay. So this is basically called as Euclidean distance. How do you calculate the magnitude? How do you calculate the distance of a vector from the origin or from any point which is represented in 2 dimension, 3 dimension? We specifically use this generic formula. And this is nothing but it is called as Euclidean distance. Okay. Euclidean distance. Now once I have computed everything of such, then finally I will go ahead and compute my cos theta, which is nothing but 6 divided by 6.872 multiplied by 2.646, and the final output will be approximately equal to 0.586. Okay. Now the cosine distance, that basically means the similarity score between the Avengers movie and B movie, is something like 0.586, right? Which is nothing but you can just say that it is similar of 0.586, which is nothing but 58.6% positively similar. So if a person is probably watching a movie called as Avengers, there are 58.6% of chance that this B movie will also get recommended. So I hope you were able to understand this specific video where we discussed about dot product. This is just one of the types, Still there are element-wise multiplication, scalar multiplication, where we'll discuss more of things about it. There are some more applications with respect to dot product since the video is becoming longer. So I will cover up that in the next video. So yes, this was it from my side. I will see you all in the next video. Thank you.